Hi, Tech Field Day Extra and Cisco Live. We are back to talk about assessing the current state of AI-driven packet analysis. This is part 2 of our discussion. I am Cobleigh with VIAVI Solutions. The little part of VIAVI Solutions that I'm a part of focuses on network performance and threat solutions. We take packets and flow data off the wire. We analyze that data for you, tell you about things that look sketchy, and help you walk through the process of understanding and resolving them as needed. Let me introduce Chris Greer. Let's let Chris Greer introduce himself.
Hi, Tech Field Day. I'm Chris Greer. I'm what you might call a packet geek. I like to look at packet traces with Wireshark and help my customers isolate and resolve issues at the packet level. When I'm not doing that as a consultant, I'm also training on Wireshark directly with the Wireshark Foundation and helping to get people trained in understanding Wireshark. Just last week, Wireshark released their Wireshark Certified Analyst certification. So I'm one of the certified instructors for that. So excited to continue to build and assist the packet community.
All right, thanks, Chris. For those of you who watched part 1 and were wishing there was more Chris, we're going to take care of that request right now. So in the first part of our discussion, we talked a lot about how current LLMs, popular LLMs, will handle PCAP data. What we want to talk about now is some of the practical challenges of the PCAPs themselves, because what many of you know all too well is if you sit down and just start capturing packets without being very, very tight on what you want to capture, those PCAPs can get incredibly voluminous in a big hurry. And then, to use the metaphor that Chris alluded to earlier, you've got a haystack the size of Cleveland, and the needle is still the same size. So what do you do to make that entire exercise more efficient and the outcome more successful? So Chris, why don't we bring you up here and have you talk about that a little bit. What are some of your best practices? What are some of the things you recommend when it comes to managing large PCAPs? How do you avoid having a large PCAP in the first place?
Yeah, that's always a goal, if possible, is to getting that packet trace as small as possible. And then I have less to look through. Problem is that you start capturing and you start wrapping into the megs, gigs, hundreds of gigs of data very quickly. I think, as we all know, speeds and feeds increase and you just start a capture and it's tremendous the amount of stuff that's in there. So now my question becomes, okay, what matters? So to Ward's point, that huge haystack, how can I get it down to be something more manageable? If a client of mine calls me and says, hey, they're having a problem, my first question is, okay, what do you have there? What type of packet capture solution do you have? Like, what are we working with? And so if they have a purpose-built solution, wonderful. We can go back in time. Now I want to know, when did the problem happen? Who was involved? Loosely, what application were they experiencing with it? It gives me some abilities to go set filters and extract that traffic. Problem is if they don't have that. Right? So then we have to set up that capture. What I'll do, if they don't have a whole lot of hardware there, what we'll do is we'll start up Wireshark and do a rolling capture. So it captures a gig, saves it, captures a gig, saves it, captures a gig, saves it, until the problem occurs. And that way, at least after the fact, okay, so Jim says, hey, it happened, and then we can go stop that capture, and then I at least have a window of a few gigs to sort through instead of a terabyte of data. So that's my first goal, is to try to get those packet traces as small as I can. And with Wireshark too, when I'm doing Wireshark analysis, really I don't want to open up a PCAP much larger than a gig. That thing can slow down. You set a few filters and every time it's got to run it through its dissectors and try to rip through that data again. It can take minutes to apply that. So just to save that for myself. Or another way, if possible, what I'll do is I'll use the command line tools to say, hey, here's a packet capture, just rip out that conversation. Going back to the AI conversation we had before, help me to create that script, help me to create that command to rip that out quickly. But yeah, managing large PCAPs is absolutely a challenge. So the goal, try to get down to as small as possible with filtering and even the way that I capture it from the beginning. So that's always a goal. And it is a challenge, and sometimes that can be pretty significant in a large data environment.
Can I run a hypothetical by you? Let's say that we're looking at, a complex multi-tier app. Maybe there's some pieces in the cloud, maybe there's some pieces on-prem. How how do you know that you're capturing in the right place? How do you know you're capturing root cause versus maybe a symptom of root cause?
That's a huge challenge. As soon as you say multi-tier, as soon as you start going into systems that are interacting with each other to deliver the application, huge challenge on the wire. It just takes the needle in the haystack to the next level. So now I'm not just looking at a needle in a haystack on a front end, on a VIP or a load balancer. Now as I'm digging into that application further, it's just, now those haystacks just get bigger as I traverse a tier. So huge challenge. What I'll do though is I just try to key on anything I can front to back, be it a conversation, be it a delay. Like for example, earlier we were looking at a pretty significant delay, like 100 seconds on that server. Okay, and now I at least have a 100-second window to look at. What else is that machine doing within that period of time? So yeah, manually, oh, absolutely, it's a challenge.
Okay, cool. So if you're kind of wondering why is VIAVI up here with Chris Greer, who is known for his packet expertise, a lot of what we do is helping our customers get the right packets at the right time from the right place so that they can be as efficient as possible in their analysis. We have the ability to collect literally petabytes worth of information, but no one's going to analyze petabytes worth of information. And so our job isn't just to take all that information off the wire. Our job is to help people figure out what it is they ought to be looking at. And so we're not trying to replace packet analysts. We're trying to give packet analysts an opportunity to be rock stars, an opportunity to thrive because they're looking at the right information the first time instead of staring at that massive haystack and trying to figure out where to start. So to that end, forgive me, I wanted to just explain how we go about finding the right packets. And I'll just walk you through an example. This is actually something that happened a few years ago at VIAVI, and we had to use packets to get to the root of the problem. We started off with a high-level service performance view that told us our Salesforce application was really struggling. And the way we knew that was because of something we do. It's a patented machine learning driven thing called end user experience scoring. And so what we do is every socket connection starts off with a score of a perfect 10. But as we see any inefficiencies begin to manifest themselves, we start to deduct from that perfect score. And we then assign those deductions to a problem domain. Is this a network thing, a client thing, an app thing, or a server thing? And so in this case, the deductions were largely in the category of server. And then we try to be more specific as we can. In this case, we're saying, hey, this server had some significant long responses to requests. Okay, so we know we've got an app problem. The dashboard tells me how pervasive it is, how severe it is. So I'm going to prioritize this and go dig into it. Once we move past that top level, we start getting down into what are the worst performing servers. And here we saw 2 servers that were performing poorly. Let's go dig deeper. And the first thing we want to do is understand the context that these servers sit in. So we open up something called an on-demand application dependency map. This is based on the real packets we pull off the wire. So this isn't based on a document someone created 6 months ago that may or may not have been right 6 months ago and is most certainly not right today. This is actually what we're seeing in real time. Now, what we observe on the left there are 5 clients that are accessing Salesforce, and all of those lines are red. If we were to hover over them, they would all have low EUE scores. And so our thought process initially might be, well, I got to call Salesforce, or I got to go figure out, what's wrong with that piece of this service architecture. But we see another clue towards the right, and that prompts us to want to look at the rest of this application architecture, because we all know if you're dealing with a multi-tier architecture and you've got problems on the back end, they are not going to fix themselves or get better by the time you reach the front end. So in this case, what we were looking at was users accessing Salesforce.com, obviously public cloud app. Salesforce had an integrated plugin called QuoteEdge. QuoteEdge is a third-party plugin that lives in a different cloud. QuoteEdge was dependent on information that VIAVI would provide through our own on-premises database servers. So on-prem database servers being queried by QuoteEdge, being queried by Salesforce, being exercised by end users. That's the full picture of the service domain that we're looking at. So now on the back end, we see yellow lines. That means red flags. So we start diving into these individual servers and we see, yep, these back-end servers are having some issues. Where do we want to go next? From here, we're going to use something called connection dynamics, which is essentially a way of saying, take me down to the individual socket connections and visualize them for me. So here we see a list of all the socket connections. We can see each connection, how it was scored. I just picked the one that was the shortest duration because it was bad enough to look at, and it's easier to look at a small conversation than a large, lengthy conversation. So when we dive into that one socket connection, we see our EUE score again. We see it's still the server domain that we're looking at. And over on the right, we see sort of an SMS style bounce back and forth. Question?
Yeah, hi, Josh from Diversified. Where is your point of entry on capturing this information, architecture perspective? Is this something that's on each application server through your multi-tiered application? From a packet duplicator, from the network, all of the above? If you got to get some context on that.
Absolutely. Thank you for stopping me there, Josh. I appreciate that. In this particular case, our frame of reference was our VIAVI data center. So we had our packet capture devices, appliances, some of you may have heard of gigastores, were deployed there in our data center, and we were capturing all the data coming in and out of the data center. Now, it's really dependent on each deployment where else you might deploy. You might have said, well, we really need to get some sort of packet capture capability in those cloud environments. Well, if it's salesforce.com, they're not going to let me put packet capture out there, so what else can I do? We don't do anything at this point that's agent-based, so we're not plugging anything into user agents or server agents, but we have found if you get good instrumentation at those aggregation points where the traffic is coming together, you can understand what the end user experience is, even if you're not on that end user device. But one of the things we do, I really appreciate the question, is sometimes packets aren't even the right answer, right? It might not be feasible to have packet capture everywhere you might want it. So then what else is there? Can we use flow to our advantage? Is there some other data source that we might use to help paint this picture? So if you look at the conversation, okay, that's cool, pretty visual, but we said this is a server issue. So we just want to look at the server side of this. So we filter everything else out. And now as we start scrolling down through the server responses, we see, hey, there's one particular server response that is obviously not, it's not what we need it to be, not what we expect it to be. So this is as far as we attempt to take you in the workflow. From this point, what we've done is we've gone from there's some Salesforce users complaining, or our dashboard tells us Salesforce looks like it's having issues, to understanding the entire service architecture, to understanding it's a server problem, to looking at one conversation, one response time, and guess where we're going to go from here? The little button at the top is packet export. There's your PCAP. But now when you generate your PCAP, you're just looking at this one small connection between this one client and server. Everything else has been set for you. The filters have been set. You've now got a small manageable PCAP that you can use to continue your analysis. So Chris, I don't know if you had any thoughts on whether or not this kind of approach aligns well with some of the challenges you were just discussing, or any other thoughts on that?
Oh, absolutely. I mean, just getting to this screen with this number of packets, what do we have, Word? Just a few hundred, I think, on the bottom, or is it? Yeah.
Can't read it, it's too small.
It's too small. Yeah, even getting to this point in that type of environment, I can't tell you how long that could take with just Wireshark, just on the wire. I mean, that's, and that's, you know, having the right capture in the right place with the right filters can still be a tremendous challenge. So what I like about this, though, is that you saw the text message conversation on the previous screen, you know, the pretty charts and screens. I mean, with me, my head, you know, I'm a packet guy. So I'm like, okay, that's pretty, that's great, but I still want the data. I still want to see those headers. I want to see what TCP's up to, what the health is. So for me, I mean, what I like is I can just do an export and then get right back into Wireshark. So high level context, getting me down, filtering me down to the problem domain, back in time, export to packet capture. I mean, that's it would save me a ton of time.
Appreciate that, Chris. One of the things we heard loud and clear from our customers, we came up with this EUE thing and people were like, that's nice, but at the end of the day, I want packets. A lot of the users of our tool are very focused on packet level analysis. And so what they said is, by all means, keep innovating. We love it, but make it as easy as possible for me to get to packets, because at the end of the day, where I'm going to be in many cases is here. So just help me get here with context, help me get here efficiently, and help me figure out what I'm looking for when I get here. So just to kind of recap what we talked about here in part 2 of our conversation, I borrowed this from, it might have been Mike Panaki that I heard say this actually. Don't try to move a mountain with a shovel. You can do it, but it's going to take a while. and you probably don't want to. Or, the metaphor we've been using with the haystack, speeds and feeds aren't going down anytime soon. We're going to be capturing more stuff. That's more noise in most cases when you're looking for a very specific problem. So figure out how to eliminate as much of that noise or as much of that hay as you can. And then, the reason why we're here is to stress the point that you want to leverage automated analysis to the extent you can to analyze all those traffic and all those flows, so that when you need to get down to the ones and zeros, you're looking at the right ones and zeros. So that concludes portion 2. Question, thought?
Yeah, so I'm trying to digest and come up to speed on everything that you're doing here.
Sure.
And it sounds like you're feeding the application packets in order for digestion.
Correct.
What happens if you don't feed it packets? What happens if you feed it layer 2 frames from like a .11 conversation? Is it intelligent enough to understand Wi-Fi and Wi-Fi centric problems in addition to application layer problems that are going to manifest in packets?
So our collection point is typically going to be a packet broker that's just forwarding us the stream of packets, or a span port or a tap or something along those lines. So we're going to see data presented that way. And we're going to...
If we take a layer 2 frame capture from a .11 adapter as a PCAP, can we dump it into it? And then do you understand that that's layer 2 frames instead of applications?
I've not run into that particular scenario. I don't know if you have any thoughts on this, Chris.
For sure, Wireshark, yes, but Observer, I don't believe so. And
That would be the crux of the question.
Yeah. Wireshark, yes. And one reason why, I get asked that question a lot, even as a packet analyst, like, hey, what do you do for wireless? And my response often is, there's a reason why Wireshark starts with wire.
Fair enough.
Because if I'm in a Wi-Fi environment, other tools that do radio, do signal noise, do that stuff well. In my experience, when I'm doing packet capture in a wireless environment, there's so much chatter.
So not quite VIAVI's forte.
So that's not the wheelhouse.
Okay, cool.
Yeah, and if I go back...
Great question.
Yeah, I love it. It's making me think, if I go back to Warcop's question, where are you deployed? We're typically deployed in the data center. And so what we wind up seeing is the output of the conversation started with a wireless device, but then got framed up and sent over, to the server. And we're seeing it as it comes into the data center and the response back from the server.
You've already abstracted out retries. You've already abstracted out noise floor issues. You've already abstracted out all of the layer 2 intelligent stuff that we need to know.
True.
And you're looking
right at that point.
high.
It's going to look like a client issue.
It's going to look like a client issue.
Yeah.
But you're not going to know what it is.
Right.
I'm assuming if you're not looking at the L2 information.
Yeah, valid observation. We're not trying to get that information from the wireless infrastructure, but thank you. That made me think about that one.
Ben Story here from Red Eye. So to kind of piggyback on yours, you were talking about, can you put a PCAP into the system, from a third-party source? We often run into it where, we're troubleshooting the issue from 2 different ends. So we may have your device in the center and we get a packet capture from the client that's out in the field somewhere.
Mm-hmm.
Is there a benefit to bringing those two together in your system?
So I'll answer from the VIAVI perspective, and you can add whatever you like here, Chris. So right now, we don't have the ability to have you introduce a PCAP and then run through our analysis and produce what you saw here. We have to capture that, and we have to analyze that, as it's happening. And I'll just pause there and say, but stay tuned. Because it has come up that both for performance use cases and threat use cases, it could be very beneficial to be able to just ingest a PCAP that was captured elsewhere and do some processing, do some analysis.
I think one of the things I've seen in the past is when you have it from both sides, you suddenly notice that there are certain packets that didn't make it all the way across the internet to the other side that you're capturing from. So.
Yeah.
Well, frankly, your use case where you were feeding the LLMs is precisely it. I've got a PCAP. I want to know what's inside the PCAP.
Yep.
How do I do that with VIAVI?
Yeah.
like that's a very valid use case.
Yeah. Now we can, and again, it depends on the customer environment. We can deploy multiple gigastores at multiple points across a global enterprise and then correlate what those things see, right? So there is the ability to say, I'm capturing packets from 4 different places, bring that all together and provide me with one unified view. So, but again, it's predicated on the fact that we're collecting data for our platform from our platform, and not just a PCAP that somebody grabbed somewhere else.
Well, Eric Stewart, University of South Florida, as you indicated, sometimes people are like, we're in the cloud, what can you do for us?
Yeah.
You kind of have to go, not a whole lot.
Yeah.
In case they can always cap on the VM itself.
So let's talk
Feed
cloud.
that to you, so.
And some of the brokers, right,
Yeah.
have cloud appliances. So
Yeah.
if you want to take a broker, you can drop it into the cloud. You have a third-party device that can give you that PCAP information. But the native would be a challenge, I think.
Yeah, this is a great point that you both brought up is what do we do in the cloud? It's funny, we have this state of the network survey we do every year, and we asked, one of our survey questions was, are you collecting packets in the cloud? And it was something like 79% of the people said, yep, we sure are. But then when we broke it down by function, the vast majority that said yes were at senior levels of management, and the people that said no, we'll just leave it there, right?
Yeah.
So
Whenever
Sounds about right.
whenever I have to troubleshoot something that's in the cloud, we are using a Palo VM, and we don't do a PCAP on it. We just look at the logs, and we can usually get what we want out of the log.
yeah. So there's a couple options here. I love this topic. So let's start with AWS. AWS makes it pretty easy. There's a native packet mirror function that you can use, so you can capture packets, and then you just have to worry about how much it's going to cost you, and that's an issue we all understand very well. VPC flow logs, pretty easy to get out of AWS environment, so that's another possible source of data. If you can make those VPC flow logs look like bidirectional conversations, we can bring them into the mix, and that's what we do. So AWS, you can go to Marketplace and download an AMI and put a virtual gigastore in the cloud, essentially. But then if you start moving outside of AWS and you get into Azure, Microsoft put out their vMirror capability a while ago, then withdrew it and said, just kidding. And then, you have to rely on third-party packet brokers. You have to put a Gigamon or something out there. Now they've recently, within the last month, reintroduced a traffic mirroring capability as like a public preview. I forget the term they use for it. It's still not like a fully GA thing, but it's at least they're heading down a path that says we're going to let you get packets again. And they threw out NSG flow logs and are now going with VNet logs. So they're changing the way they look at how logs describe what's happening in the cloud. And then with Google Cloud, packet capture, I think, not impossible. Logs are really hard to figure out because their VPC flow logs are sampled, and then they allow you to establish a second sampling interval. So samples of samples, which scares me as a data source. So I'm wondering how much integrity is left in the data. I'm sure there's a reason they did it. People smarter than me built that, but I have to worry, especially in a multi-cloud environment. Over here, I'm going to get packets from AWS. Over here, I'm going to get VPC or VNet flow logs from Azure. And over here, I'm going to get samples from Google Cloud. And I'm going to try to pull all this together. It's not exactly seamless. So some real world challenges. And that's why we all get paid the medium bucks to try to sort all that out. Chris?
I have one more thing about where packets came from. I mean, one challenge I run into constantly with my clients is where did they get this from and how did they get it? And if it's a high throughput environment and they say, well, I put Wireshark on a laptop, I put it into a span port and just hit capture, and I'm thinking, like, are you aware of how little that can actually capture reliably without altering the delays? For me on my YouTube channel, I have a few tests that I've done where I've just hammered traffic across the bow of a packet capture or a laptop trying to keep up with it. And the throughput is I have to crank it down to almost 50 megabits per second before it can capture everything. So that's another thing that's in the back of my mind when I'm sent a PCAP and it's not a Gigastore, it's not a purpose-built hardware device. How reliably was it captured to begin with?
Expanding to a laptop's gigabit port when
Well, yeah.
the feed is a 10 gig. And it's like, well, you're not getting all the data
Right.
to start with, much less what the laptop can write to its drive in the process.
And let's go ahead and span the whole VLAN.
Yeah.
Do an RSpan or an EXpander. Like, let's bring it in from everywhere. And by the time it actually lands,
Missing.
yeah, right. I have so many blast holes in that traffic. I can't even make sense of it. So it's just another reason, to have that all in one place.
Thanks, Chris.
Yeah.
So the numbers on the clock have gone from green to red, which probably tells us we're just about done here. Thank you very much. We appreciate the audience, both in the room and remotely. Hope you guys have a great Cisco Live. We put a couple links in the presentation if you want to learn more about what this guy is all about. Some fantastic content out on his YouTube. Everything you wanted to know about Wireshark and things you were afraid to ask as well. And then also, as Chris mentioned, he's got the new Wireshark certified analyst thing going now, which is pretty darn cool and probably long overdue. So with that, again, we'll extend our thanks to those of you in the room and those of you out on the stream. Enjoy the rest of the event.
Thank you.